Assalamu alaikum warahmatullahi wabarakatuh. My name is Yusuf Muhammad Gharib, and today I will be explaining the seven great ideas in computer architecture and how simplicity and performance shape modern computing. These are the seven great ideas, and I will be going in depth in each one, and hopefully you would understand from me. And to give you an overview of what is the seven great ideas, they are timeless design principles that help engineers build faster and more reliable and more efficient computing systems. Going forward, the first one is abstraction. Abstraction hides low-level details and help us focus on the bigger picture. For example, the user does not worry about how the system works. He only gives us the input and expects an output. He does not care about how the system performs or what the instructions are done to get this information. He only cares about what he gives and what he takes from it. Going on to the second great idea, it is make the common case fast. It is in which design systems to optimize operations that happen most often. Like it is like a grocery store. You make the main aisle wide because that's where most people walk. In computers, CPUs are designed to execute common instructions like addition or comparison extremely quickly because those are the most frequently used in the programs. Moving on to performance via parallelism. This is where multiple operations or tasks run at the same time to increase speed. For example, a multi-core processor run multiple threads in parallel. To explain to you what it means, parallelism means doing multiple things at the same time. Modern processors have many cores so they can run multiple tasks together. It's like having several workers each doing part of a job instead of just one person doing everything. This is dramatically increases performance, especially for heavy tasks like gaming or video editing, for example. Moving forward to the fourth most great idea, performance via pipelining. It is in which breaking tasks into smaller stages and overlap them like a factory assembly line. For example, while one instruction is being decoded, the next one is being fetched. To give you a brief, it is like instead of waiting for an instruction to finish before starting the next, computer break each task into stages and overlap them. So while one instruction is being executed, the next one is being decoded and another one is being fetched. This overlap helps the CPU work more efficiently and faster. Moving on to the fifth great idea, performance via prediction. It is in what guess outcomes to save time. If you're often right, you gain a lot of speed. For example, given here in the slide, branch prediction guesses the result of if statements in code. Prediction is all about guessing what's going to happen next to save time. CPU use something called branch prediction to guess which direction a program will go, especially after an if statement or a loop. If the guess is right, the CPU saves time. If it's wrong, it just fixes the mistake and moves on. It's a smart way to avoid delays and keep the system moving faster. Before the last great idea, we have hierarchy of memories. Memory is layered by speed and cost, going from registers all the way to magnetic tape. Not all memories in a computer is the same. We have small, fast, expensive, and memory like registers and cache, and slower but larger memory like RAM and hard drives. This is called a memory hierarchy. It helps balance speed, size, and cost so the CPU gets fast access when it needs it, but also has lots of space for that. Moving on to cost, the last good, the last great idea, dependability via redundancy. Backup systems ensure reliability even if parts fail. Example is a RAID storage system use multiple disks for fault tolerance. Redundancy means having backup in place to the system that doesn't fail. For example, servers often use RAID, which stores the same data on multiple hard drives, right? If one drive fails, the system keeps running without losing anything. This makes computer more reliable and able to handle failures without crashing. Why these seven ideas matter? These are principles to guide engineers, computer architecture specialists on how we design efficient, reliable, and fast systems. They apply to phones, supercomputers, cloud servers, everything. Thank you. Any comments, any questions? I will be delighted if you give me any comment. Thanks.